Hey all, so here's a video to help you guys out with problem number 45 on the homework, since it covers a few topics beyond what we covered in class. And we're doing a live, this is being recorded in front of a live studio audience, as I call it. There's a couple of students here. So if you hear questions in the background, that's them helping you guys learn from this video. Anyway, so the first thing, anytime you're dealing with circuits, the first thing that you're going to want to make sure to do is you need to choose a direction for the current to be flowing through each different object or portion of your circuit. And so I went ahead and did that. You might choose right, you might choose wrong. The key is when you solve, if you get a negative value for your current, all that means is that you chose the wrong direction, and instead of flowing down through a battery, it flows up. Instead of flowing to the left, it flows to the right, and so on. So what I did is I decided to choose that the current is flowing in the upward direction through R1, E3 here, then it's to the left as a result, again following this direction. It's going to be to the left through the R1 up at this point, and then I also chose, and you'll see why later, that I chose up for the current flow through E2 and R2 in the middle, and then as a result of that we're going to have current flowing then to the left through the R1 at this point, and as a result, in order for this to work, you're going to need it to be flowing down through E1. Now that seems counterintuitive for a lot of people to have current flowing from negative to positive through a battery, but a current is going to just follow the path of least resistance. So it can flow in the negative direction through a battery if that's how the potential differences cause the current to flow. So that's, while it seems counterintuitive, is not impossible at all. Okay, so that's the beginning. Now let's think about what else we have going on here. So let's consider, one thing to observe is that we have these 2 points that have been labeled for us, kind of a hint that they become important, point A and B. What we know is the potential difference between point A and B is going to be the potential difference between A and B, and it doesn't matter what path you take from going from A to B, the potential change is the same no matter what. So if you go from A to B in this direction here, up and then over, you're going to get the same potential change as if you take the straight path this direction, or if you go this way around from, I guess this is from B to A, excuse me. Okay, so let's just think about that and consider that for a moment, and we're going to use that throughout the course of solving this problem. So the first thing I want to think about is looking at my batteries 2 and 3. The reason that I want to start by looking at batteries 2 and 3 is because they have the same amount of EMF acting on them as the problem statement tells us. So let's consider batteries 2 and 3, and so we're going to be looking at currents 2 and 3 as well. I'm just erasing some of my beautiful drawings here so that I can not get too confused with what's going on. Okay, so I still have my currents, I1 here. Alright, so if I go go through battery 2, if we notice what is going to happen in that path. So as you go through battery 2, you're going to have a potential gain equal to E2, then you're going to have a potential drop of I2 times R2. So if we look there, we have let's change colors because yellow is just not that easy to see. Oh, that worked well for erasing. Okay, so we're going to have, this is a beautiful video already. So you're going to have E2 as a gain, and then you're going to have a loss of R2 times I2. Alright? Then, if you go the same route, you know that must be equal to or the same as going through battery E3. So if you go through battery E3, you're going to have a drop right here. So you're going to have a drop of R1 times I3. Then you're going to have a gain plus E3. And then you're going to have another drop of R1 times I3. Okay? So rewriting this whole idea, what you're going to see is that you have E2 minus R2I2 is equal to E3 minus 2 R2I3. Okay? So that's cool. Sounds good. Notice from your problem statement, regardless of what your values are, your E2 and E3 are equal to each other, so those can be canceled out. And what is the relationship between R2 and R1? I think that I have a typo here. This should be R1. What's the relationship between R2 and R1? Anybody from the crowd?
Siblings.
Well, R1 is double R2, right? If you look at your problem, R1 is double R2. So what that means then is this term and this term are the same, and what you can determine from this is that your I2 value is equal to I3. Cool, that's nice, that's a bonus. So I'm going to go ahead and just use the variable I to represent both I2 and I3. Now the cool thing is, and this is something that we're going to learn more in class tomorrow, but a real cool thing that you can observe then, this point A, the total current coming into it and going out of that point must be equal to 0, right? If you think of it as water flowing through a pipe, the amount of water flowing into a junction in a pipe must be equal to the water flowing out of that junction. So based on how we drew things, what that means is that our I1 value must be equal to I2 plus I3. Or, if we just use this variable I that I came up with, we can rewrite this and say that I1 is just going to be equal to 2 times this I value, double the current that we have going through battery 2 and double the same current going through battery 3. Okay? So, that's nice. That makes our life a little bit easier. How, from this, can we then solve for what this mysterious I value is? We now have all of our currents in terms of one single variable, but we still need to solve. And so in order to solve, I want you to try to follow the same procedure that I used here. It's a little sloppy, I apologize, but use the same procedure and analyze the change from point A to point B, taking a path that takes you through battery 1 this way, and taking the path that takes you through battery 2 in this direction, okay? And you can travel left to right or right to left, A to B or B to A, doesn't matter, totally up to you. But I want you to compare those two and use that information to try to solve for your current value. Go ahead and give that a shot. Let me know if you need any hints or more help, and we will be solving these types of problems a lot more and get more of the information of how to do it tomorrow.